Welcome to the Quick Train Modeler video training series. This module will introduce you to the indexing tool. New in Quick Train Modeler 7.1.3, the indexing tool provides you with an easy solution for inventorying your geospatial data holdings, including LiDAR point clouds, raster datasets, and vector datasets. The indexing tool can be accessed by going to the Export menu and choosing Create File Index. This launches the Create Folder Index window. Before we get into how the indexing tool works, I'd like to talk a little bit about the data I'm going to be using for this demonstration. I'm going to be using the indexing tool to inventory close to 900 files that comprise over 17 gigabytes of data. I have some ground control points in a single shapefile, a whole set of JPEG 2000 imagery data that's been tiled, a single impervious raster dataset, a set of LAS point clouds, and finally a handful of QTT surface models. The first step in the indexing tool is to select the folder that you want to index. Click on the Select Folder to Index button. Here you'll select the root folder that contains all the data that you want to index. Down in the lower right, you'll see that I have the checkbox selected for recursive subfolders. This means that Quick Train Modeler is going to dig through any subfolders or subfolders within those subfolders and inventory all of the data. The second step is to select the KMZ index file. This is the output KMZ file that's going to open in Google Earth. It's going to contain the Google Earth version of the index of all of your geospatial datasets. You also have an option to select an output vector index file. To do this, click on the Select Vector Index File button. While the most common format for the export vector option is ESRI shapefiles, you can also export the data to the CSV format. Now we can choose how we want to organize our data in the output index files. We can group it by the current directory structure, or choose the radio button for Organize by File Type. The Organize by File Type option is extremely useful if you have a bunch of similar format data, say LAS files, scattered across a series of folders. Generate a search cache. This is very useful because it speeds up indexing. It's a one-time function, and it also will speed up the image search and data search functions available to you within Quick Train Modeler. The indexing tool will work on a broad range of geospatial datasets. Any type of LAS files, QTA, QTC, or QTT models from Qt Modeler, a whole set of raster datasets including JPEG 2000, ERDAS Imagine, ECW, and even shapefiles. It won't work on text formats. This includes ASCII data and CSV data. For more information on the formats, click on the Help button. Now that we're ready to execute the indexing tool, we're going to click on the Go button. Although I compressed the time it took for the indexing tool to run on all of this data, it was less than 30 seconds for tens of gigabytes of data and many hundreds of files. As soon as the indexing operation is complete, Google Earth will launch. You'll see in my Places window I have a new index file called index.kmz. Click to expand that file, and we see that it's organized by directory. This is the option that I chose within the indexing tool. If we just want to take a look at the LAS files, those files I had within my LAS folder, which are my point clouds, I can turn off the other index layers. Zooming in, we can clearly see the tile outlines that correspond to the extents for each one of the LAS files. If I click on one of these point markers here, it opens up a whole host of information about that LAS file. If you look at the top of this info balloon, you see Open File and then a hyperlink to the LAS file. Clicking on this file will automatically launch Quick Train Modeler and display that LAS file. Let's see how this works. There we have it, our point cloud corresponding to that index file displayed within Quick Train Modeler by clicking on the hyperlink. If you find that clicking on the hyperlink is not launching Quick Train Modeler, please make sure you go to Tools, Options, General, and under Place Mark Balloons, check the box next to Allow access to local files and personal data. Before we exit out of Google Earth, I'd like to stress that the indexing tool has worked not only on the LAS point cloud data, but it's also given me an extent for my shapefile, a tile index for all of my ortho imagery, the extent for that single impervious raster dataset I had, and the tile boundaries for that handful of QTT surface models. Now let's move over to ArcMap. Displayed within this ArcMap document, I have that ground control points vector layer and that impervious raster dataset. Now let's go ahead and load that index shapefile I generated using the QuickTrain Modeler indexing tool. By opening up the attribute table for this index shapefile, we can see the QuickTrain Modeler has created an inventory of all of those vector, raster, and point cloud datasets. Similar to how I did it in Google Earth, I can use the Identify tool to click on one of the polygons and then use the hyperlink file to automatically open that LAS file within QuickTrain Modeler. If you find that the hyperlink function isn't working for you, go into the properties of your feature class. Within the Display tab, make sure you check the box Support Hyperlinks Using Field and select the Path field. You may have LiDAR data that has an unknown coordinate system associated with it. If this is the case, a list of those files will be created in the resulting index file, but there'll be no geometry associated with them. It is worth pointing out that you can use QuickTrain Modeler to write coordinate system information into LAS files using the batch scripting tools, but we'll cover this in another tutorial. We hope you enjoyed this video. Please visit the Applied Imagery website for more QuickTrain Modeler videos, and check back often as new modules are being added all the time.